Hi, this is Remembering the Past, the show where we talk about people who've died recently who've had a profound effect on our history, our society, or our culture. And in our ongoing series on Nobel Prize winners, tonight we're going to talk about Dr. Arvid Carlsson, who died recently at the age of 95. Dr. Carlsson was awarded one-third of the Nobel Prize in Physiology or Medicine in 2000, sharing it with Dr. Paul Greengard and Dr. Eric Kandel for their discoveries concerning signal transduction in the nervous system. Let me try and clarify what Dr. Carlsson specifically did. He identified a compound called dopamine as a chemical neurotransmitter. What that means is this. The nerve cells in the body are not directly connected to each other. There's a slight gap between nerve cells called the synapse. The way one nerve transmits its signal to another nerve is through chemicals that go across the synapse. Now, this had been well known for some time in peripheral nerves, that is, nerves outside the brain and spinal cord. But it was not clear that chemicals were used inside the brain to transmit from one nerve cell to another. Scientists weren't sure if nerves in the brain transmitted their signals through chemicals or through electrical impulses. It was known as the soup or spark theory, soup being chemical transmission, spark being electrical transmission. Gradually, in the 1950s, scientists realized that chemicals were used for neurotransmission in the brain as well as in the peripheral nervous system, but they did not realize the importance of dopamine as a neurotransmitter, and that was the first thing that Dr. Carlsson discovered. Here, Dr. Carlsson explains the importance of dopamine as a chemical neurotransmitter in the brain.
Concept of chemical transmission in the brain depended very much on this early work on dopamine. Dopamine was really the molecule that paved the way for the concept of chemical transmission in the brain. That also became clearer as time went by. The reason why it took such a long time was that dopamine started out, as a really something that nobody thought could simply be of any importance. And then over the decades, people have started to realize, look, here comes dopamine. It's involved in everything. So therefore, the stock of dopamine has grown over the decades. Okay. So finally, so many people understood dopamine is terribly important.
One of the things Dr. Carlsson did was figure out how important dopamine was. He noticed there were high concentrations of dopamine in an area of the brain called the substantia nigra. In working with rabbits, he noticed that if that area of the brain was destroyed, or if dopamine was blocked by using chemicals, that the rabbits developed tremors and halting movements that looked exactly like the symptoms that patients with Parkinson's disease had. The dopamine levels at that part of their brain were very low, so he treated them with a compound called L-dopa, because that crossed the blood-brain barrier, whereas dopamine did not. And sure enough, their symptoms disappeared. He theorized that the same thing would happen in patients with Parkinson's disease, and consequently, it was his work that led to the development of L-dopa as the first treatment for Parkinson's disease, and dopamine congeners in one form or another are still used to treat Parkinson's disease today. In fact, I remember when I was a student, I remember one of the first patients that was treated with L-dopa that I followed in medical school, and it was one of my English professors from college, and they were still working out the dosage and the intervals and everything like that, and this was in the mid-70s, and it all emanated from Dr. Carlsson's work. Dr. Carlsson spent virtually all of his career in his native Sweden. He was born in Uppsala. As a medical student at the end of World War II, he helped take care of Jewish prisoners of war. Then he studied pharmacology at the University of Lund. He was actually working in calcium metabolism, which had nothing to do with his later work. And his Swedish mentors persuaded him to go into neurochemistry in the brain. I have a feeling that they were interested in the neurochemistry of depression at the time because they were working a lot with a drug called resembling. Depression was a big problem for Sweden after World War II. A lot of suicides in Sweden, a lot of Ingmar Bergman movies. I'm just speculating on that, but it just seems interesting that Dr. Carlsson was encouraged to go into neuropharmacology. That was also abetted by a half-year stint he did here in the United States at Bethesda in the late 1950s with the noted pharmacologist we had working there. Anyway, he became a professor of pharmacology at the University of Gothenburg in the late 1950s, and that's where he did his Nobel Prize winning work. As a young professor, he challenged a lot of his elders at an international conference on the Sparker soup theory and neurotransmission in the brain.
In those days, when the electron microscopic pictures came, one was so impressed by the compactness in the brain. I mean, everything was so very close. Whereas in the peripheral system, the nerves were not in that very tight contact with the whatever muscle or heart, whatever you have. So I think that was one factor really to help the Spark people to keep the brain. That was not the only reason why there was so poor acceptance in 1960 of our findings. Another one was that we claimed that dopamine was a neurotransmitter. And all pharmacologists in those days knew dopamine is an inactive compound, because if you test it in the peripheral system, on the heart and gut and whatever, it doesn't do anything. I mean, it's in contrast, of course, to noradrenaline and adrenaline. So dopamine was considered to be just an intermediate in the synthesis of these other compounds, and having no physiological importance in itself. So that was another factor. So there were several factors like that. There was also some evidence at this meeting that actually never got published, and there probably was no evidence actually that these compounds, noradrenaline and so forth, they are not located in nerves, they are in glia cells, in the supporting tissue. So there were so many arguments that were piled up one on top of the other. So everybody was impressed by all these arguments that were against the idea of dopamine being a neurotransmitter. It's funny that in retrospect things look so simple, and at the time it was very complicated.
As I said, this was all going on in the late 1950s, early 1960s, and he wasn't awarded the Nobel Prize until the year 2000, so it was a 40-year hiatus, and he joked about that late in life.
Well, I think I can have two comments. One is that for Einstein it took 20 years. For me it took 40 years, which means that my problem was twice as complicated as his.
One of the interesting things about Dr. Carlsson's career is that after he finished his work with dopamine and Parkinson's disease, he went on to do other neuropharmacology that was nearly as groundbreaking. He was instrumental in the work on drugs called selective serotonin reuptake inhibitors, or SSRI drugs, serotonin being another neurotransmitter in the brain. Most well-known of those is Prozac, which his work was critical in. They are now a mainstay of depression treatment, and in fact, when they were introduced in Sweden, they dramatically lowered the suicide rate in the country. And he also did important work on the drug class known as beta blockers. So besides his Nobel Prize winning work, it's safe to say that he was one of the leading neuropharmacologists and biopharmacologists of the 20th century. But late in life, he lamented the fact that his type of work, that is the link between pharmacology and physiology, was falling on hard times.
Doesn't look too good. It's not just pharmacology, it's also physiology, actually. The integrative aspects of body functions and the outlook of this part of science into the clinical applications. This is not being very much favored at this time, because that's because of these staggering discoveries in genes, molecular biology. Everybody is moving in that direction, and that is away from integrative aspects of physiology and pharmacology, and therefore there is really not enough training of new people in this field. That's true of both integrative physiology and integrative pharmacology. And this is something that you will get into if you are trying to really develop anything in physiology and pharmacology on the basis of animal work. You will have to go into the integrative aspects. It's not enough to have a molecule or a cell, because the most difficult thing is things to go into. The most complex thing that we have in our bodies is how all these different cells and organs, how they are operating together, and how it is controlled from the brain and the endocrine system and all that. This aspect is now not being considered enough, and there isn't enough people being trained for this very important aspect. But you have to get through that in order to really to get the final answer of what is important for the human being. You must go through this part of the integrative aspects of physiology and pharmacology, and that is going to become a great problem. There is so much, the cell by itself, of course, is enormously fascinating. So people are just, they're focusing on the cell. They are so fascinated by the cell. But the cell is just one step. Then you have to go into how all these cells, how they're operating together. That's even more intriguing, I think, and even more important to understand. Well, everything is important, of course. All the steps are important for the full understanding. There will be a change, of course. The pendulum will swing back, but it will take some time still, and it will be a tough thing to regain what has been lost, I think.
Like many of our Nobel laureates, Dr. Carlsson looked fondly on his mentors when he was young, who were so critical to the development of all these great scientists, and he talked about one of them.
What he could do, he could encourage people. Yeah. He kept telling me, you will become a great man. And he also guided me in a nice way, such as to broaden my experience.
Well, as you've heard, Dr. Carlsson had a good sense of humor, and here he jokes about his retirement.
I had reasonably good funding till my retirement. Then at the time of retirement, that's a big problem in Sweden as a retired person, because then you are pushed off. I was fortunate even from that point of view, because I got a very good research collaboration agreement with Upjohn, the American Upjohn company. So that could help me to go on. Actually, nobody has given me any thanks for my retirement. And sometimes I think, why didn't I get any thanks? Well, that's because I didn't stop, It's my fault, actually, that I would never thank.
Well, I'm going to close on that note. I want to thank my producer and IT genius, Sid Tepps. What to close on for Dr. Carlsson? Well, I'm not impressed with the Swedish composers out there, and I don't want to use any ABBA music, so I'm going to go with one of my favorite singers, who stopped singing because she has Parkinson's disease, and I'm going to have her sing one of the best songs by the greatest of all American composers. Unfortunately, we won't be hearing Linda Ronstadt singing live anymore, but here she is singing George Gershwin's Someone to Watch Over Me as a final tribute to Dr. Arvid Carlsson.
There's a somebody I'm longing to see. I hope that he turns out to be someone who watch over me.
There are people who are so to say in the Nobel Prize career, and where they think in their choice, in their research, which one to take, which is best for me as a candidate for the Nobel Prize. I have never had any thinking like that. I've always, what I found that is the most exciting from the research point of view, I have chosen that.